Hi everyone. So what we're going to do is we're going to go over the regression analysis worksheet. So the first problem is to do with crickets. Believe it or not, when crickets do chirp, you can calculate the temperature of out. Usually the crickets are outside. So we have some data here. We have temperatures and we have chirp. And of course, the way they did this experiment is they had a thermometer and they were counting the chirps, and then they, they match the two numbers, right? The chirping and the temperature. And based on some information, some data, some bivariate data, right? They put it into a regression analysis or regression formula to see if there was a pattern. And so that's what we're doing here. So temperature is going to be X and chirps are going to be Y. This is going to be L1. This is going to be L2 for our calculators. And if there's, on the test, it's going to be pretty clear which is L1 and L2, okay? And usually the first column is X, second column is Y. So don't worry on the test. It's going to be more specific. But if you're a science major, you usually know that temperature is X. But I know not everybody's a science major. Okay. So utilizing the calculator is going to be very important in this particular problem. For the test and the quiz, it's going to be very similar, right? There might be a problem where you have to do the columns to do the sums. But to save time, because doing the regression, it takes a little while to do the calculations by hand. So doing the sums is much easier, or doing the correlation coefficient as well. Finding the sums do help. And to do that, we have to use our calculator. Okay, so here on the right, you can see my calculator. I'm going to go through stat and edit. And what I did already was put the data on the first column for temperature and the second column for the chirps. And if you go over here, this is L1 and L2. I have some L3 and L4 data for the next problem. So you got to be very careful too. Which column are you adding your data in, right? Okay, so it says right here, use your calculator, right, to find the sums. And so, and it's right here too, see? Using sums above by using your calculator. So we're going to go to stats, we're going to calc, we're going to go two variables. We're going to say L1, comma L2, because I know that we're using the first two columns. We're going to enter. If it looks different, it's because you have the wizard. And then, bam, all this information is on the calculator. And so it's best to write down these values. It's really important to keep in mind that when you transfer these numbers, you got to make sure you copy all the numbers right. Because, for example, if you leave that 5, right, this whole thing is going to be wrong. Let's say you leave out that 4 and you make it a 7, the answer is going to be different. So it's kind of like accounting. You got to be very careful in copying over all the values. And one of the other thing that you'll find out is, right now we're doing correlation coefficient, right? It says right here, find R. But you're also finding these other values, right? SX, SY, right? Which is the standard deviation for Y, the standard deviation for X. And why would you want to do that? Well, because we're doing part B as well. Where do you find this information? You also find it on the calculator, okay, on the right side of the screen here. And the only reason why this is working where you have SX and SY, right, as variables, is because you said it was a two variable statistics, right? You're like two variable statistics. Yeah. When you go to stats, you go to calc, you go two variable, right? It's right here. Two variable stats. And so when you click on that, right, the calculator knows that you're doing two variables. And thus, that's why if you look at the calculator again, there's basically two columns of information. First column is X, the second column is Y. Pretty neat. Okay, let's see what else. So we pop it into our regression formula. There's a lot of steps, you know. You might want to even write down somewhere the formula, and you have to pop in the values correctly, right? Because if you don't, you might make a mistake. Like over here, this is the sum of x, y. This is n, right? These values here, right? Those 478, right? That's the sum of x and the sum of y put together. These values all have to be in the particular order. Okay, so that's very important. Watch my video, my video on how to put these values. The number one thing that most people have issues with is the algebra. It's not really the statistics, it's the algebra. So you have to practice on that. There's no way around it. Okay, so here, as we can see, after we put in these values here, right? And don't forget that there's a square root. Here you multiply, here you multiply, here you're going to square, here you're going to multiply, here you're going to square. And it's always done the same way. After you multiply, you have this value. You have the subtraction. When you multiply this, you have this value here, right? So that's correct. And then, in this case, multiply, you get this value. Subtract. When you square this, you get this value. Multiply, you get this value. When you square this, you get this value. You can see you still have the brackets. Oops, right over here. The brackets, right? Here are the brackets. Here are the other brackets. Here's the other bracket, right? So now you have two numbers here. One thing that you also have to be concerned about, and a lot of you already know this, but the sum of x, quantity squared, is not the same as the sum of x squared. Now, if the two values are the same, there's something weird is going on. It's just, coincidence. Keep that in mind, because a lot of times we will put, this right here, which is the sum of x quantity squared. Sometimes we'll put the sum of x squared. We'll put this value in here, and then we square it again. That's a big one that a lot of people do. Okay. So here, and then we're going to draw it here. Okay, so I won't forget. Make sure, I want to do it in black. Make sure you take the square root. Okay. Okay. That's important. And you can see here, we'll subtract, but you still keep the brackets, which are right here. See that? You can always go back. Remember, this is a video. So if you're like, oh, you're going too fast, well, then just review the video and just go over and listen, what did he just do? And then after you subtract, right, you got to multiply because they're brackets, right? The brackets will tell you to multiply these two values. You have it down here. Yeah, I know it's kind of small, but it's there. This value goes there, right? and you still need the square root. And then after I took the square root, and you have the top number here, you have a fraction, and then you got an answer. Okay, cool. We'll get to this answer. We're going to check. Okay, yes, you can always go in the calculator and check. But let's do the next problem, and then we can check both answers, all right? It's good practice to check this answer to see it's right. Okay? That's best practice. Check that before you do this. But, to save some time over here, I'm going to do this here. And it says right here, using the sums above, calculate the linear model, right? The regression, right? The model, the linear regression, the least squared regression, right? And it says show work. And it says right here, using the sums. So we're going to be using these sums, right? These sums. Okay. So in this case, right? And I'm going to be clear on this. And I'm sorry if this is different. On the test, it probably won't say sums, okay? Use the it's probably going to say use the alternative form. I'm going to delete this, okay? Sorry about that. If you use the sums to calculate, that's fine. It's going to say use the alternative form, right, to calculate the linear model, all right? If you use the sums to calculate the slope and the y-intercept, that's fine too, okay? Pretty flexible in that. But in this case, we're going to be using the alternative form, meaning we have these values right here. Okay. So for A, we need R, which we have from what we did before. We need SY that we got from the calculator, right, which is right here. SX from the formula. SX is this number, which goes here. So we substitute the values that we have from our formula. Where do we get our formula? From the notes. And then we have this right here. We pop these numbers, we get this value here. What is that? That's going to be A. What is A? Right? Remember, it's y hat equals ax plus b. A is the slope. So you gotta keep that straight. Okay. Then B. How do you calculate B? This is the formula for B. You're gonna need y bar, x bar, and A, the number that you just calculated. So one thing again that you need to open your mind is like everything seems to be stacked, right? You got to do R first, and then you use the A formula, and then you use S, Y, and SX with R to give you A, where A is the slope. So all these things you gotta sort of like remember. What is A? You should have some notes and say A is the slope. How do you calculate R? Oh, it's the R formula. Whatever it is that you need to do to keep this in your mind. Maybe you need to use cards or something, or a sheet, just one sheet that gives you all the steps to help you understand the workflow. When you do this, when you do this many times, it's like it makes sense. When you do it the first time, it's like, wait a minute, so many letters. Yes, that's true. But as you do it again and again, it makes a little more sense. So that's the point. You got to practice. All right, so I have the formula here. So I need y bar. Where do I get y bar? Well, you found it. It's right here. And y bar is right there. You have a subtraction. There's a subtraction. This is a. This value is a, so it goes in there. And then x bar. Well, x bar is over here. So that's why it's over here. So we take the formula, we substitute, and when we get these values here. That's a lot, isn't it? It sure is. And then we multiply, keep the subtraction, and then we subtract these, and we get this answer. What is that? This is b. B is the y-intercept. And so the general form, right? The general form is y hat equals ax plus b. And as we know, we've calculated a. That's why it goes here. X is just x. Plus is the general form. B is this value right here. And that goes here. So the answer, it says right here, calculate the linear model. You need to put it in this form, right? You don't put it in this form if you just leave these numbers. If this is 10 points, you'll probably get a +7 or plus, I don't know. Yeah, +7, right, out of 10. Because you forgot to put it in the form, right? Which is very important. And then it says right here, how many chirps are predicted when the temperature is 80 degrees? Well, you pop in 80 for x. And how do I know it's for x? Because it's temperature. You look over here, it says temperature. You pop in 80, you multiply, you subtract, and there it is. Right? So now you have the temperature of 80, and then you can figure out the chirps. And you can always go the other way around also. If you pop in how many chirps, you can figure out the temperature. But usually temperature is the independent variable, which is x. Now, let's check for understanding, right? Let's see what's the value for r. So if you go to stat, you go to calc, you go to regression. But before we do regression, I think it's under regression, isn't it? Yeah, maybe. It might be under regression, right? Yes, which is R. So we got to make sure we're in L1 and L2, right? I just clicked on the list. And then we have an R value of 0.983, which I wrote down before, and it's very close to the answer that I want. Okay, so that tends to be one of the things that tends to happen is that you might not get the right answer, right? 0.98, you might get a 5 here, right? Or 0.998. And what's happening there is you're not keeping all the numbers after the decimal place usually. Okay, or you might have mistyped a number. So just keep in mind, if your answer, right, this is the answer, of course, but if your answer becomes 0.9584, we know that you did something wrong. If your answer is 0.9763, okay, you're close to 0.98. If your answer is 0.997, well, something went wrong, but it's sort of acceptable. Okay, of course you have to show your work. Thing is, the more numbers you put after the decimal place, the better it will come out. Now, be careful when you're over here in the screen on the right where it says lin reg, be careful. You see over here, you might think, oh, that's A and B. But why is it that they don't match? They don't match because remember on our first lesson, we talked about how, um, you know, there are different ways of describing linear regression, right? The linear model, write down the model, write down the least square regression, right? There are so many ways of describing, creating the line of best fit. All these words come from different fields. And, our form is y hat equals ax plus b. In statistics, when you take when you take like master's level statistics, it's going to be a hat equals let me see if I remember this. It would have to be bx plus a. All right. Y, I don't know. Um, you know, you would think it would be a first and then b, but it's not. So if you look over here, these letters are wrong. The letters are wrong, but the numbers are right. So how do we get the correct form? Well, you got to go to stats, right? You got to go to calc. Don't go to regression. Go to linear regression. You see that? And it's in the form of ax plus b, which is the correct form that we want. Then we type in L1, comma, L2. Enter. And then we have the answer. You see that? A is equal to, B is equal to. And then this is A and this is B, which the numbers are right. But you can see that it didn't type out the form, right? It didn't, you have to put it into the proper form, the equation, to get the full credit. All right. Wow, that's a lot, isn't it? A lot of work there. But it's well worth that work. Okay. Let's do the next one. Next one's going to be easier. So here, something about time students in the class studied for a test. Okay. And fortunately, it gives you X and Y. So I already typed in these numbers. They're over here on L3 and L2, right? This is L3. This is L4. Oh, sorry. L3 and L4 right here. Okay. Then it says use your calculator to find the linear regression. Oh, that's easy. Stat, calc, linear regression of ax plus b, number 5, L1. No, not L1, L3, comma, L4, right? You got to pay attention. Enter. And bam, just write the answer out, right? I got to write out y hat equals whatever a is, x plus whatever b is. And then boom, done. Okay. Yes, I put more than 3 numbers after the decimal place, which is fine. All right. What else? Next one says, what's the correlation coefficient? Okay. Stat, calc, and then correlation coefficient we can find under regression here. We got to make sure we choose the right L, the right list. It's L3, L4. Done. Did it give me the right answer? Yes, see, it's right here. Okay. We got to change this because if you're not paying attention to me right now, then you're going to get it wrong. You got to choose the right list. Okay. Don't assume that, R, okay, I'm going to, done. And you're right, the answer from the previous problem. Here it says, using a linear regression equation, predict a test score if it's 8.5. So what we do is we take 8.5, put it into our formula, then we multiply, then we add, then we get the predicted score based on the data that's above here. So this data here allowed us to create, and you can see it on the right, over here, right? Over here on the calculator on the right, you can see that the calculator has given us an equation of the straight line. Let me see. I don't know if we can I make a copy of this? Let's see. Hold on here. There you go. As you can see, let's see if I can do yellow. Over here, right? This part right there. Hold on here. Right? That part, if you look at it, you can see that these are all the data points. These are the data points, the little stars. And the red line is the best straight line that it can draw. So when it's asking you, what happens when you have 8.5 hours? So 8.5 hours is, I'm going to estimate. It's like over here. Here's 8.5 because this is X. So what it's telling it, what the problem is asking for is that use the red line or use the formula to figure out what the answer is. And the answer is going to be somewhere in there, which is close to 83 because this is Y. Okay, so this red line gives us the best straight line based on all of our data points, based on some calculations, right? The residuals, if you remember in our lecture, right? If you remember our lecture, let me saw this. If you remember our lecture, this was the thing that we were talking about residuals. Remember these things right here. So the calculator is also doing that for us as well. And based on those residuals, and based on the minimization of the residuals, which you don't have to do, but when you take some calculus, it gives us the alternative forms that we need to calculate A and B. Okay, the last part is pretty interesting. It says here, based on the regression model. What is a regression model? Same thing as the least square regressions or the regression, right? For every hour they study, how would their test score change? So to do this problem, you don't place 1 hour in here. When you have a problem like this, right, and it says based on the regression model for every hour, when they say for every hour, it means what happens every single hour, right? Not what happens. Not what happens the first hour, the second hour, the third hour, the fourth hour, right? It's not like what happens when you do 8 hours, what's the test? But in terms of like what happens to your test score if you just study 1 extra hour or 1 hour. Well, it turns out that you take the slope, you pop, and in this case it says every hour, it says every 10 hours, or every 2 hours, or every 8 hours, right? You pop in whatever they ask you in here, and then you get this answer. Because see, B is the y-intercept, right? B is the y-intercept, right? And if you think about it, B is constant, right? Let's say the line was going this way, which it is, right? If you look over here, right? This is X, this is Y, this is the hours studied, right? And this is the test scores. This particular axis, right? So this is Y. So what happens is they want to know this slope piece, like how if I study 1 hour more, right? 1 hour more, what would happen to my overall test scores? How would it how would it increase? How would it increase in terms of my test scores? Well, in this case, every hour that you study, it would increase your test score by 1.2 more percent, which is not a lot, is it? Every hour I study, it's going to give me another 1%. Yeah, it's possible based on the data that you have here. So if I study 10 hours, it's predicted that I'm going to get maybe 10 more points on my test, probably, you know. So, but there's a baseline, right? So we're going to erase this here. We're practically done on this problem here, where this is the answer here, and it says right here, let me show you something else. It says right here, for every 1 hour the study, their test score changes that much. You see, again, let me draw it better maybe, because this is a very interesting idea here. Because what's happening is that there's here on B, let's say the score, let's say the 70, right? Let's say it's 70. Let's forget this this problem with the data, right? This is X, this one's Y. If you don't study, or you study you don't study, because this is 0. If you don't study, you're probably going to get a 70. Most likely not, right? Most likely not. There's probably something going on when you go into class. There's a minimum. You go to class, you study, or something like that. Let's not say 70, okay? Because then you might think, oh, I don't need to study. Let's say 50. Okay, let's say 50. Okay. And then as you study more hours, right? 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6, 7, 8, 9, 10, 11. Then after the 11th hour, maybe you'll be getting 60%. You see that? And the more hours you spent, the higher you get. The higher you get, then maybe 70, right? Maybe after 20 hours, you get a 70. Maybe the material's that hard. Not everybody that studies 20 hours will give you 70 because they're not very effective maybe in studying. But that's the whole point. The whole point is you put more time, your scores will go up. Not everybody is going to be the same, though, like I said. Student A and student B, if they study 10 hours, are they going to be getting the same answer? No. But if they have a similar background in terms of education, in terms of who they are, maybe, most likely. Because most students that come from Dominguez Hills come from the usual Southern California area. And they usually have the same, backgrounds. Not all students. I'm generalizing. But on an average, most students have a similar background or a similar amount of knowledge. And so you can determine a pattern for them. And thus, you can create these type of statements where, in this case, every hour that you put in, then there seems to be a 1.2, basically a 1.2% difference in your test scores. All right. Okay. Wow, that's a lot. And the idea in this piece right here is use your calculator, find the answer, right? The analysis of test scores, like, do I need to know anything about test scores? No. But everybody should have a sense of what test scores are. So having this idea of test scores helps you maybe generalize it when you go into your other fields of study. All right. Good luck, and we'll see you soon. Bye bye.